Hello everyone, good evening. So here we shall solve from question number 7 onwards. So in question number 7, has been told that line L is the bisector of angle A and B is any point on the line L. BP and BQ are perpendiculars from B to the arms of angle A. Show that triangle APB is congruent to triangle AQB and BP equal to BQ or B is equidistant from the arms of angle A. That we have to prove it. So now here, first we have to write what is given. Given is that line L bisects angle angle A, and BP and BQ are perpendiculars on the arms, on the two arms of angle A. Then we have to prove that first part is triangle APB that is congruent to triangle AQB. And second part is we have to prove that BP is equal to BQ or B is equidistant. B is equidistant from the arms of angle A. B is equidistant from the arms of angle A. Okay, so then the proof is first we have to prove that triangle APB is congruent to triangle AQB. So here, as you can see that, so it is told that line L bisects. So it means that AB is the bisector. It is the bisector of angle QAP. Is given. Therefore, you can say, therefore, in triangle APB and triangle AQB, sorry, triangle AQB, you can say that angle PAB that is equal to angle QAB. Since why it is given that AB is the bisector of angle QAB. And we can see that AB is the common side. So therefore, so the figure is like figure was this. This is B, this is A, this was A, this is the line L, this B, this is Q. So here we can see that triangle PAB, that is angle PAB equal to angle QAB. Since why this is the bisector, AB is the bisector of angle QAB, and angle BPA that is equal to angle BQA. Since why both are right angles, both are 90 degree, which is also given. Since it was given that BP and BQ are perpendiculars on the two arms of angle A. Arms of angle A. So, and we can see that AB is the common side. AB is the common side. You can say AB is equal to AB also. So hence you can see that hence triangle APB is congruent to triangle AQB. How? By angle side. By AAS rule, by AAS congruence rule. by A is congruency. So therefore, we can say that VP equals to VQ. PQ equals to BP equals to QB or BQ, which is by CPCT. So hence we can say hence B is equidistant from the two arms. B is equidistant from the arms of the angle A. So hence proved. Then in question number, this was question number 8. So in question number 7, it has been told that line L and M are two parallel lines which are intersected by another pair of parallel lines P and Q. So here it is given, and we have to show that triangle ABC is congruent to triangle CDA. So first we will write what is given. Given is that L is parallel to M and P is parallel to Q. And L intersects P and Q, the lines P and Q, at A and D respectively. A and D respectively. And the line M intersects P and Q, the lines P and Q at B and C respectively. So hence we can see that ABCD is obviously a parallelogram. So we can see that ABCD, quadrilateral ABCD, quadrilateral ABCD is a parallelogram. Since you can see that since obviously AD is parallel to BC and AB is parallel to DC. Since it is already told that P is parallel to Q and L is parallel to M. So now we have to prove that triangle ABC is congruent to triangle CDA. So here obviously you can say that the diagonal AC has to be drawn. So that we can write in the given only diagonal AC is drawn. Then, so this should not be a part of the construction, since by here it is already asked to prove that triangle ABC is congruent to triangle CDA. So we have to write it in the given only. We should not write it in some construction. So then we have to write the proof. So the proof is we will write in triangle ABC and triangle ABC and triangle DCA. So here you can see A, obviously it corresponds to C and B corresponds to D. So ABC we should tell CDA. ABC is congruent to CDA. So in triangle ABC and triangle CDA, you can say that obviously angle ABC that will be equal to angle CDA. Since the reason is that in a parallelogram, the opposite angles are equal. In a parallelogram, the opposite angles are equal. And then obviously AC equal to AC, or we can simply say AC is the common side. And we can say that this angle BAC that will be equal to angle DCA. Since why they are alternate interior angles. So angle BAC that will be equal to angle DCA is their alternate interior angles are equal. Alternate interior angles are equal. So hence by AAS rule, we can say that these two triangles are congruent. Therefore, we can say that triangle ABC that will be congruent to triangle CDA by AAS rule. By AAS rule of congruency. Since it is angle side. Since here this side is not the included side. This AC is not the side which is included in between the two angles which we have considered. So it is the rule that is to be used is AS, not AC. Then in question number 9, it has been told in adjacent figure 9, AC equals to AE, AB equals to AD, and BAD equals to EAC. So that BC equal to DE. So here, first we have to write what is given. The given is that in triangle ABC and triangle ADE, AB equal to AD, AB equal to AD, and AC equal to AE, and angle BAD that is equal to angle BSC. We have to prove that BC equals to DE. BC equals to DE. We have to prove this. And then we have to write the proof. I will say that in triangle ABC and triangle ADE, since it is told that AB equals to AD, which is given, and obviously AC equal to AE, which is also given. And we can see that angle BAD, we can say that angle BAD, since it is equal to angle AC, so I can say angle BAD plus angle DAC, that will be equal to angle DAC plus angle EAC, or which implies that angle BAD plus angle DAC means it is angle BAC is equal to angle DAC plus EAC, it means it is angle DAE. So hence we can see that angle BAC is equal to angle DAE. So this is the included angles. This one is the included angle. And here also the reason will be given only since on both sides we have added the same angle. So therefore you can say triangle ABC is congruent to triangle ADE of by SAS rule, by side angle side rule of congruency. And hence, so we can say that BC will be equal to DE by CPCT. So hence proved. Then here it is told that AB is a line segment and P is its midpoint. AP is a line segment and P is its midpoint. B and E are points on the same side of AB such that angle BAD that is equal to angle ABE and angle EPA that is equal to angle DPE. Show that triangle DAP is congruent to triangle EBP and AD is equal to PE that we have to prove. Now first we will write what is given. The given is that P is the midpoint. P is the midpoint of line segment AB, or hence I can say AP is equal to BP, and D and E are points on the same side of line AB, the same side of line AB, such that angle BAD that is equal to angle ABB and angle EPA is equal to angle DB. Then we have to prove that first one is triangle DAP is congruent to triangle EBP. Triangle DAP is congruent to triangle EBP. The second is AD is equal to BE. Then we have to write the proof. So I will say that in triangle DAP and triangle EBP, you can see that these two angles are equal, means angle DAP that is equal to angle EBP, which is given only. Since we BAD and DAP, they are same angle, and ABE and EBP, they are also same angle. And you can see that angle here it is told angle EPA. So if we add the same angle, which is angle EPD, EPA plus EPD, that is equal to angle EPD plus angle DPB. Since we can write the reason is given. So this implies that angle EPA plus EPD that is equal to obviously angle DPA. So angle DPA that is equal to angle EPP. And also we can see that AP is equal to BP, which is given. So this AP is the included side. So we have to tell by ASA rule, by angle side angle rule of congruency, these two triangles are congruent. So therefore we can say that triangle DAP is congruent to triangle EBP. And the reason is by ASA rule of congruency. And so I can say, so AD equals to BE. So AD will be equal to BE. How? By CPCT. So hence proved. So hope all of you understood the solutions of all these questions. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.